Welcome to VLSI Simplified YouTube channel. Uh, as 30 days of Verilog lecture series, I completed with this flip-flops related to the flip-flops. I completed in the day 9 part 1, that is uh, latches and flip-flops I completed. Today we'll go with uh, we completed in the flip-flop, we completed with uh, SR flip-flop and D flip-flop. So today I'm going to explain about the JK flip-flop and T flip-flop. The two I will execute in EDA Playground and Vivado as well as Quartus Prime and Model Sim. Okay. So if you see, this is EDA Playground. So today we'll discuss about JK flip-flop. So this is the code and test bench for the JK flip-flop. So if you see the code and test bench, so my module name is JK flip-flop, input clock, input J, input K, and output reg Q. So why we are using Q as reg data type? I am using in the procedural block. Okay, Q I am using in the procedural block. That's why in the port rule connections, you know that we need to indicate Q as reg data type. Okay, so when you are using the behavioral modeling. So this is the procedural block. Always at the rate passage of clock begin. Okay, I'm using case statement. Case. Okay. So in the concatenation operation J comma K, two tick binary 0 0, it will be in memory state. Q equal to what? Q. Two tick binary 0 1. So Q equal to that is a one tick binary 0. It will be reset state. Two tick binary 1 0, Q will be non-blocking with set state. Two tick binary 1 1, Q will be non-blocking with the toggle state. Okay, based on the truth table only, I wrote in the case statement end case, end module. Okay, so this is the code for JK flip flop. Okay, and coming to the test bench module, my module name is JK flip flop underscore TB. So I need to declare clock J and K with reg data type and Q with Y data type. So I need to instantiate my design. So how to instantiate means I am using connection by name. So here this design name followed by this design name and this design name both should match. Design name followed by the instance name and dot clock. Whatever the variables outside the bracket are design inputs and outputs, variables inside the bracket are test bench variables. Okay, and I need to generate the clock. How to generate the clock? Initial begin clock equal to 0 forever hash 5 clock equal to not of clock. So here, so I'm generating a clock that is it should be off for 5 nanoseconds and it should be off on for 5 nanoseconds. Total time period is 10 nanoseconds. Initial begin. So for getting the waveform, I need to use these two commands. $dump file next jk flipflop.vcd $dump var 0 comma jk flipflop underscore tb. So I'm giving the value j equal to 0, k equal to 0. After 10 time minutes, I'm giving the stimulus. That means I'm driving the values to the DUT, design under test. Okay. Mm, so j equal to 1, k equal to 0. After 10 time minutes, I'm giving j equal to 1, k equal to 1. After that, I'm terminating the simulation end and I'm writing the monitor signal. That means dollar monitor is a system task. If there any change in this values, it will display. Okay. So time is percentage t, j equal to percentage b, k equal to percentage b, q equal to percentage b. I want to display in binary. That's why format specify. And time also I want to display dollar time j comma k comma q end and end module. Okay. So this is my code. This code I'm going to execute in EDA Playground. Okay. So in EDA Playground, as you aware of this, we need to write design on right side and test bench on the left side. Okay. So this code I'm copying. Hope you understood this code. So copy this code and here we need to paste and test bench. So test bench, copy this code and here we need to paste the test bench. Go to the tools and simulators, select Altec Revera and open EP waveform after run and save. So run. So we'll get the waveform. See here. So that means when here you see when j equal to um, j equal to 1, k equal to 0. So during the passage of clock, it will go into set state. Okay. And when j equal to during this passage of clock, okay, during this passage of clock, j equal to 1, k equal to 1, it will go to high. Okay. Here j equal to 0 and k equal to 1, reset state. Okay. And during this passage of clock, I need to check j equal to 1, k equal to 1. It will be toggle state. So that means previous state is 0, it is going to 1. That is toggle state. Okay, like this we can verify the truth table for the JK flip-flop. Okay, so in the log file also you can get. See here, j equal to 0, k equal to 1. So reset state, j equal to 1, k equal to 0 set state, and j equal to 1, k equal to 1. So that is a toggle state. Previously it is 1, no? It will go into the toggle state. Okay, so like this we can see. And coming to the Vivado project, new project, next. So mm, uh, I think I will open the project. Already I created the project, no, in the previous session. I'll open the project, that project. Flip-flops I created. Okay, flip-flops. Okay, this project I'm opening. Okay, so within this flip-flops only I'm adding. Previously I wrote for RS flip-flop. Okay, and T flip-flop. So here itself I'm writing this codes. I'm adding the design source. Okay, so add the design source. Next, create the design source. Okay, so give the module name as design source. What is my module name? JK flip flop. Okay, this is my module name. Copy this, and here you paste, choose the location. Okay, location is flip flops only. Okay, finish. Okay, yes. So this is my JK flip flop. Here, go to this code, copy this code, and here you paste, save. So whatever you want to see that design, you need to right click and set as top module. Okay, and go to the simulation source, add the simulation source. Next, create the simulation source. So give the test bench name only, jk flip-flop underscore tb. Copy this, paste over here, and choose the location where you want to store this files. Okay, finish. Okay, yes. Yeah, this is my jk flip. This is my tb file. Okay, so just copy this code and paste here, save. So you want to see the simulation, right click, set as top module. Okay, so you'll get like three dots in like rectangular shape that shows that this is the top module. And I want to see the means elaborated design. So go to RTL analysis, open the elaborated design. Okay, how the tool is converting your RTL code into gate level netlist, I want to see. Yeah, we'll see how the gate level netlist is coming. So like this you are getting in terms of mux and D flip-flop, it is converting means depending on the possibility. So we given the case statement, no? So it is converting like 4 cross on mux, okay, like this you are getting, and it is giving to the D flip-flop. So like this it is converting, tool is converting our code into RTL design, okay, RTL like in gate level netlist, okay. So next coming to the simulation part, go to the run simulation, run behavioral simulation. So if you see here in the TCL console also you will get, see here when j equal to 0, k equal to 1, q equal to reset state, j equal to 1, k equal to 0, set state, j equal to 1, k equal to 1, that is what means toggle state. Okay, so you can see in the waveforms also, just to fit to page. Here you see during this passage of clock, what is j and k? J equal to 0, k equal to 1. Okay, that means q equal to 0 only. During this passage of clock, j equal to 1, k equal to 0. So it will go to set state. Q will go to set state. Okay, here q will go to set state. And here what happens? J equal to 1, k equal to 1. So again it will toggle. It will toggle from 1 to 0. Okay. So like this, we can see the waveform as well as the gate level netlist in Vivado. Okay. And next, coming to the quarters, first new project wizard. Next, so choose the location where you want to save this project file. So training and development and mm, VLSI design method 30 days. We are in day 9, no? Day 9. I created three files, RTL, SIM, and TB. Okay, I need to select this SIM. And so, how the uh, module name is there, the same name you need to give. Okay, so in RTL, I give the, this is my RTL file. So, here my module name is what? JK underscore flip-flop. Okay, so this is what? JK underscore flip-flop. Okay, so next. Yeah, next, and here add the RTL code, day 9, RTL, add this JK flip-flop file. Okay, so added, uploaded this JK flip-flop .v file. Next, select any FPGA family board. Next, next, and finish. So now my device, my RTL file is added. So go to analysis and synthesis, start. Yeah, I got zero errors and one warning. So go to this analysis and synthesis, netlist viewer, RTL viewer, and open. So in quarters like this, it is converting. Okay, means in terms of vectors, it is there like selection line 1 down to 0. So there we have seen the 4 cross 1 mux. No, here this is also 4 cross 1 mux, but in terms of vector, like data is 3 down to 0, selection is 1 down to 0. Okay, like this, it is converting. The tool is converting. Okay, and coming to the model sim, so file, so here I'll create one project. Okay, new project. Yes, I want to close this. Project name is JK underscore flip flop. So same path. Okay, same path I gave. Okay, I need to add the RTL file and TB file. JK flip flop. Okay, Okay, and add the TB file. Go to TB, JK flip-flop, open, OK, close. Okay, so select these two, right click, compile selected. Okay, so compile selected. So both are compiled. Go to library, work function. So here this JK flip-flop is there, no? Just you need to simulate TB file. You need to do the simulation. So my simulation started. So here what you need to do here, right click, add wave. Okay. So here the waves are, the signals are added. Okay. DUT also, if you want to add wave. So I want to group this TB files and DUT files. So just these are the TB files. Make a group. So these are my TB files, and coming to DUT files, right click, group, DUT, OK, and run. Okay. So no. So I'll get the simulation here. So just expand this. One second. Yeah, zoom fill. Here you see. So that means here during the passage of clock. Okay, during this passage of clock, Q is 0. Sorry, J is 0 and K is 1. Q is 0 only. During this passage of clock, J is 1, K equal to 0. So you are getting Q equal to 1. And during this passage of clock, J equal to 1, K equal to 1. So it will be toggle state. Okay. So like this we can see in the VBAD. Okay. So why we are going for JK flip-flop means in SR flip-flop there is a one invalid state. When S equal to 1, R equal to 1, that is an invalid state, no? So that we are going to use as a valid state with some modifications, some more connections, so that we are getting as a toggle state in the JK flip-flop. Okay. So this is about the JK flip-flop. And next, coming to the, so as I told you, from SR flip-flop, we will get the D flip-flop as S and R are connected with an inverter. From JK flip-flop, we'll get the T flip-flop. T flip-flop, and when J and K are connected together. Okay. So when J and K are connected together, that is a toggle flip-flop. So only two states will be there. When J equal to 1, K equal to 1. That is a like present state. When J equal to 0, J equal to 0, K equal to 0. That is present state. J equal to 1, K equal to 1. That is toggle state. Okay. So from JK flip-flop only, you'll get the T flip-flop. Okay. So this is the code. So I'll open first EDA. So this is T flip-flop, T flip-flop. So here if you see module T flip-flop synchronous reset, input clock, input reset. I'm using synchronous reset. Okay. So input T, output reg Q. Okay. Synchronous reset means here whatever the means whether it is going from reset mode to functional mode or functional mode to reset mode, that is synchronism with the clock. Okay. Synchronous with the clock. Okay. So always at the rate passage of clock. So in the sensitivity list, you need to represent only passage of clock, and begin. It is active high reset. Active high reset means what? When reset equal to 1. So Q becomes 0. Q becomes 0. Else if T. Else if T. So Q equal to not of Q. Toggle. Toggle state. Okay. Q is non-blocking with not of Q, end and end module. Okay. So this is the Verilog code, RTL code for the T flip-flop with synchronous reset. Okay. So just when reset is applied, Q will be means make to 0. Else if T equal to 1 means, so we already seen the truth table for T flip flop. When T equal to 0, so that will be the same state. Okay. When T equal to 1, that will be what is the next state? Toggle state. Okay. So that means when T equal to 1, it will be Q equal to not of Q. That is toggling condition. Okay. And next, this is the test bench module T flip flop. So clock, reset, and T I am declaring with reg data type, and Q I am declaring with Y data type. So I need to instantiate my design. How to instantiate? So this is a design name followed by the instance name, and I'm using connection by name. Okay. Initial begin clock equal to 0. I'm applying an initializing clock equal to 0. I'm generating the clock forever hashtag clock equal to not of clock. Okay. So I'm generating the clock with 10 nanoseconds time period. Initial begin. Okay. Multiple statements are there means we need to write between the begin and end. So these are the two instructions for executing the waveforms in the EDA playground. $dump file t underscore flipflop dot vcd $dump vars 0 comma t flipflop underscore tb. So first I'm applying the reset. Okay, when applying the reset, I'm t equal to 0. Anyway, q equal to 0 only. Okay, after 10 time minutes, I'm deassetting the reset. Okay, I'm making t equal to 1. I'm checking for driving the values to the DUT. Okay, after the t, so here when t equal to 1, I am giving. So it should go into which mode? Toggle state. When t equal to 0, it should go into memory state. And when t equal to 1, it will go into toggle state. Again, I'm applying reset. So again, I'm applying reset means what? The output should go to 0. Okay. Again, reset equal to 0 and t equal to 1 means again it should go to toggle state. And dollar finish is terminate the simulation. And initial begin dollar monitor as system task. If there any change in this any of the variables, then it will display. It's always monitor for change in the variables. Okay. End and end module. Okay. So this is the Verilog code and test bench for the T flip flop. So now I will execute this code in EDA playground first. So copy this code, go to EDA playground. Uh, so new playground I'm opening. So copy the design code and next paste the this one test bench. This test bench. Uh, so go to tools and simulators, Aldec Rivera, and open EP waveform after run. Save and run. I'll get the waveform. See here. So I need to check for T. Okay. During the passage of clock, I need to check for T. Here, see here. So here when and reset also. So when reset equal to 1, okay, till the reset equal to 1, q equal to 0 only. Okay. When reset is deasserted. Okay. So when reset becomes 0, then reset will be deasserted. Okay. Then it will go into functional mode. Okay. So during this, so here reset is deasserted, but this is negate. I need to check for passage. I need to see for T input. Okay. So what is the T input? T is so T is 1 over here. So that means Q becomes initially it is 0, it will toggle to 1. Okay. And during next passage of clock here, during this passage of clock, what happens? I'm checking for T. T equal to 0. So T equal to 0 means it will stay in the memory state, previous state only. What is the previous state value? 1 only. So it will stay in 1 only. Okay. Again, during this passage of clock, T becomes 1. So T becomes 1 means it will be toggle. So previously it is 1. It will toggle from 1 to 0. Okay. And next, see here. Here during this passage of clock, so here what happens again reset is applied. Okay. Reset is applied means irrespective of clock and input, it will force the output to what? 0 only. Okay. Reset is having the highest priority. So when reset is deactivated only, I need to check for T input. Okay, here T input is what? T input is 1. So T input is 1 means during passage I need to check. Here passage. T input is 1 means again it will toggle from 0 to 1. Like this I can check the waveform. Okay. You can see in the log file also. See here. When T equal to so even T equal to 1, it will be reset state. Initially it is 0, it is coming to 1. And next when t equal to 0, memory state, previous state only. reset equal to 0. So t equal to here t equal to 1. Again it's toggling. Again here reset is applied. At 45 minutes reset is applied. So Q becomes 0 only. So again at this one, okay, after 10 minutes, t equal to 1, reset equal to 0, it will toggle to 0. Okay. So like this I can check in the EDA playground. Okay. Coming to the Vivado, just add the design source, create the design source, give the module name only. Okay, T flip flop synchronous reset. Copy this and paste. Choose the location. Flip flop. Select. OK. Finish. OK. Yes. This is T flip flop. Copy this code and take the time scale also. Copy this code and paste over here and save. So I want to see the design set as top model in the design sources. Okay. And go to the test bench. Copy this code. Before going to the test bench, go to simulation sources, add the simulation sources, create the simulation sources. Here, T flip flop TB. Copy this, paste, choose the location, flip flop, select OK, finish, OK, yes. So here T flip flop underscore TB file. Okay, this is my TB file. Copy this TB file and copy, and here you paste, save. I want to see the simulation. Right click, set as top module. First I want to see the means a gate level netlist. Okay, open elaborated design. Yeah, like this in terms of D flip flop, and here as Q is connected through the inverter. So like this, we can design the T flip-flop by using D flip-flop. When Q is connected through the inverter, so that is actually it is acting as a T flip-flop. So reset signal is there, active high reset directly connected to the clear signal. Actually, it will be connected to the asynchronous input clear signal. Reset is given to the clear signal. This is active high. So when it is 1, reset will be activated. When it is 0, it will be deactivated. So clock is given directly through the arrow mark. It is given means this is a passage of clock. So this will trigger during active transition of clock when it is going from 0 to 1. Okay. T is connected to CE. So like this, it is converting your code into gate level netlist. And next, run simulation, run behavior simulation. So you can see in the TCL console also, whatever we seen in the EDA playground. So see here, when t equal to 0, q equal to, so here t equal, initially t equal to 0, reset equal to 1. Here reset is applied. So respect of clock and reset, it will force the output toward 0 only. So when t equal to 1, reset is deactivated, q equal to 1. Okay. A toggle, it will toggle. And when t equal to here, so when reset equal to 0, t equal to 0, it will stay in the previous state. And when t equal to 1, reset equal to 0, again it will toggle. Again t equal to 1, reset equal to 0. Here again it will toggle. Okay. So like this. Here I applied the reset. Again I applied the reset at 4,000, 40,000 time units. So irrespective of clock and reset, again reset is activated. Reset, it will go, it will make the output to 0. Okay. Like this I can see, and I can see in the waveforms also. You see fit to page. So anyway, when the reset is applied, okay, so it will force the output to what 0 only. Okay, during this passage of clock, what happens when reset equal to 0? So reset equal to 0, t equal to 1 means it will toggle. Initially it is 0, it will go to 1. Here if you see, as t equal to 0, it will stay in the same state only. Same state means memory state. And here what happens during this passage of clock, as t equal to 1, again it will toggle. Okay. So when t equal to 0, it will be memory state. When t equal to 1, it will be toggle state. And here reset is applied. During this passage of clock, reset is applied. So there is no like due independent of clock. Okay, there is no act means due to if there any clock or input, okay, the output will be 0 only. Why? Because reset is having the highest priority. Okay, and again reset is reasserted. One second, fit to page. Again here reset is reasserted during this passage of clock. What happens? T equal to 1, it will toggle to 1. Okay, initially previous state is 0, it will toggle to 1. Okay, like this we can analyze. This is EDA playground. And coming to the quarters, so yeah, so file, one second, new project wizard. Next, okay, so what is my module name? So I wrote RTL, TB and SIM, no? So, so this is my RTL file. So this is a SR flip-flop reset clock. Copy this and here go to quarters. Next, oh, sorry. This is SR, no? This is SR flip-flop. I need to open the T flip-flop. So here, copy this. Go to quarters. Save. Paste. Next and next. So add the existing file, RTL file. So this is RTL. Next T flip-flop synchronous. So uploaded the RTL file. Select the any FPGA family. Next, finish. Yeah, T flip-flop file is added. Right click, analysis and synthesis start. Yeah, I got zero errors. Go, so expand this analysis and synthesis, netlist viewer, right click, RTL viewer and see. So like this, we are getting the T flip-flop. Okay. So two more muxes are getting and it is given to the D flip-flop. Okay. So in the Vivado, just D flip-flop as Q is connected through the inverter, simply I got. Just observe the difference. Okay. So how the circuit is converting, how the tool is converting your code into gate level netlist. And go to coming to the model sim. So just a new project. Okay. And just quit sim. Okay, I want to come out from the simulation. You give the command as quit sim. Okay. So file, new project. Okay. Yes. So what is my project name? Give the file name only, the module name only. So copy. One second. Model sim. So project name, same folder. Okay. Add the existing files, RTL and TB. So RTL file, we are in T flip flop. Open. Okay. Add the existing file and TB file. So this is my TB file. Okay. Close. Next, select these two. Right click. Compile selected. And next, go to library. Work. T flip flop TB is there, no? So right click simulate. Yeah, I think we're getting error in the TB file. I think so. This I need to check. Okay. So like this, we can see the means we can see the output of JK flip flop and T flip flop in mainly in the EDA playground and Vivado and Quartus Prime and model sim. Okay, so Quartus Prime we can see the netlist, and in model sim we can see the simulation, and in Xilinx Vivado we can see the netlist as well as simulation part. Okay, so with this we completed all the flip flops SR, D, and JK, T. Okay, so next we will go with the data. We'll start with the counters and shift registers. All those things are there. Okay, thank you.